Whether you design power supplies, embedded systems, RF circuits, or audio electronics, at some point you'll have to figure out how to join separate grounds at what's often called a Kelvin connection, or perhaps even use copper geometries for RF parts or planar magnetics. Altium Designer provides a very handy tool for all of these situations called net ties. The easiest way to understand how to use net ties is to see how they're made. First, let's look at an RF folded dipole antenna. At DC and low frequencies, this would be a short circuit, so normal design rules wouldn't allow it. But we'll make it a net tie. We'll start by creating the actual antenna geometry as a PCB footprint, with a surface mount pad at each point where the RF signal will be connected to it. Then we'll create an appropriate symbol for it in the schematic library. In the schematic component properties, set the component type to net tie. Then assign the PCB footprint created earlier, and check the pin mappings to ensure the correct signal assignments. Even though the copper in the footprint is a short circuit at DC, because the components are net tie, the design rule checker understands that the shorting copper is allowed. Another really good use for net ties is the Kelvin grounds, where you have two or more separate ground nets joined at a low current location. Here's an example I made using 5 top layer pads, electrically joined together by this polygonal region shape. In this case, I've closed the solder and paste masks as well, so the pads aren't exposed. And the final example for using net ties is planar magnetics. This simple planar inductor has 2 windings spread over 4 copper layers. Buried vias are added to the component to join winding sections, and at the end of each winding is a single layer pad facilitating connection to the appropriate net on the PCB. So if you want to build RF or planar magnetic components, or Kelvin Connect analog and digital grounds, net ties are definitely the way to go.